Hello, in this lesson, I'm going to review percentile, quartile, and z-scores. This is chapter 3.4 of your textbook. Okay, question 1. Write a sentence to interpret each of the following. A. 42nd percentile of amount of electrical bill is $27.80. Okay, let's think about your phone bills. Or the electrical phone bills. Let's say I arrange the phone bills from small to big. So smallest bill to the biggest. This is the smallest to the biggest. And 42nd 42 is about here. 42nd percentile, or percentile. So here, meaning that you would have 42% of the phone bills are under $27.80. Let me write it a little better. So let me write $27.80. And that means you would have 52% over here. 58 plus 42 going to give me 100%. 42%. So I can interpret in two ways. I could say 42% of the electrical bills are under $27.80. I can also say 58% of the bills are over $27.80 per month. And in part B, the 95 percentile of a weight of a newborn baby is 3,900 grams. Again, I can, if I would arrange the weights from smallest to biggest, and then I want 95 percentile will be here. 95th percentile, meaning that which is 3,900 grams. So that means 95% is over here, 5% over here, meaning that 95% of a newborn weight will be under 3,900 grams, where 5% of the weight will be over 3,900 grams. Okay, let's write that. And in question number 2, the data set below gives the finishing time of a group of 5 years old in a race. The times are recorded in seconds. Let's notice the time here in second. So question asks, find and interpret the following. First, we need to find my quartile, Q1, Q3, and quartile range, IQR. So to process the data, first I'm going to enter the data into the calculator. To enter the data, first go to Stat, and notice editing is highlighted. So put enter, and then now enter your data. I enter my data already in advance in L1. Once I've done that, then I go to Stat, Calculate, 1var Stat, and tell my calculator that my data is in L1. Note that the default is L1 here. Okay, so put enter now. Okay, so now we have the answer. So we have X bar is 2415, and then you have a sample standard deviation. This is a sample of 5 years old. So S of X is 4.4871, and the sample 20, meaning the total 20 babies are in the data set, and minimum is 15. You have Q1 is 21. Q1 is a 25 percentile. You have median, which is Q2. That's a 50 percentile, is 23.5. You have Q3 is 28. And so I'll write down the information. So that I know that IQR is equal to Q3 minus Q1. Now, once I've done this, let's interpret that. Okay, let me draw a picture before we interpret that. So we have, let's say I have the data arranging the numbers for finishing time for the 5 years old from small to big. Okay, the smallest one, the minimum here what was the 15, right? Also, this minimum here also given in your calculator. Notice that you can go down the list, get the minimum 15. And the maximum is 33. So 15, 33. Now, if I arrange the number, all the number point here from small to big, then I would have, I divide it into 4 parts. 1 part. Okay, divide the bottom half and half again, top half and half again. Then I would get the 20, this is a Q1, which is 21. And Q2, that's your median. Let's write down the median. The median here is 23.5. And Q3 is 28. So that's your Q1, Q2, Q3. Again, median, another word for it, same thing as your Q2. So notice that means you would have 25% of the data in each, 25% here from 15 to 21. You have 25% over here. You have 25% over here from 23.5 to 28. You also have 25% from 28 of the data point from 28 to 33. So the data is divided into 4 equal parts, right? And the first part from the minimum to the Q1 is 25%. And you can also say from minimum to Q2 or the median is 50%. So now let's interpret that. Q1, again, Q1 is meaning that you can say 25% of the babies finish the race under 21 seconds. You can also interpret the upper part. You can also say 75% of the baby finished the race over 21 seconds. So either one will be correct. And for the median, for the Q3, again, Q3, know that Q3 divided into top 25% and bottom 75%. So you can say the top 25% of baby finished the race at least over 28 seconds, where the bottom 75% of the baby finish time is under 28 seconds. Now, the IQR is the range of the middle two Q1 and to Q3. So it's measure the range. So we'll say the range of finishing time for the middle 50% of the data point here is 7 seconds. So let me write that. Okay, so know that the IQR measure the range of the middle 50%. Okay, now let's look at part B. Under the IQR method, use the IQR method to determine if the data contains any outlier. Show any work that clearly state the conclusion of your any outliers. To use the IQR method, meaning that I want to find out if I have any outliers using the IQR. If outliers, meaning that maybe some is too small, some is too big. So determine outlier, we use lower fence, your left fence or lower fence, or upper fence. And we say the lower fence is Q1 minus 1.5 times your IQR, right? And then upper fence is equal to Q3 plus 1.5 times IQR. Now that any number that's smaller than the lower fence or bigger than the upper fence are considered outliers. Okay, so once you calculate, you get a lower fence 10.5, upper fence 38.5. So that means let's look for a number that's smaller than 10.5. Know that the minimum data point is 15 right here. Right, and the maximum data point is 33. So right here. So I look for, well, I don't have any data point that's less than 10.5. I also don't have any number that's bigger than 38.5. So therefore, I can make the conclusion that the data does not have any outliers. Right. So I can say the data does not contain any outliers. Question number 3. The mean weight of a man aged 20 to 29 years old is 183.4 pounds with a standard deviation of 51.2 pounds. The mean weight of a young woman aged 20 to 29 years old is 156.5 pounds with a standard deviation of 40 pounds. So answer the questions for A through C. So A, if a woman is this age group weigh 160 pounds and a man in the age group weigh 185 pounds, what is the relative, who's relative here, heavier? Now to compare two group of people with given mean and standard deviation, we use z-score. We put them in a z-score scale to see who's heavier. So first let's review a little bit about z-score. Okay, we say z-score for a population, z is equal to x minus mu over sigma. For sample, we say z is equal to x minus x bar over s. Now that mu is a population mean, and sigma is population standard deviation. where X bar is sample mean and S is sample standard deviation. So now let's convert each one of them, write down information and convert them to Z-score. Okay, so we plug in the information for men. The men's weight is 185, and the mean for men is 183.4, and the standard deviation for men is 51.2. Notice that I'm using mu here for the population mean, because we have this is the mean for the entire group of men here, entire group of people. We're not taking any samples, so this is a population here. And then for women, that woman weight is 160, and population average for women is 150.6 and standard deviation of 40. So if you plug it in a calculator, we get that for men, the Z-score is 0.03125, and then for the woman, the score is 0.0875. That means if I would draw them, let me draw them on a Z-score scale. So draw. Now remember, the Z-score is a standard normal with mean equal to 0, standard deviation 1. So mean is 0. And with standard deviation 1, meaning that you have negative 1 about, increment, each standard deviation will be 1. One segment, this is 1, this is 2, because standard deviation 1, so there will be negative 1, there will be negative 2. And so that's our standard normal. Again, note that this goes to infinity in both directions. So let's check. So well, for men is 0.03 approximately. So that would be somewhere over here. That's for the man. And then for the woman is 0.08. No, 0.08 should be more than 0.03. Let me draw a little better. 0.08 should be somewhere here. That's for the woman. Notice that the woman's score is on the right, is bigger than the man's score. It's also on the right of the normal curve, the about normal curve. So therefore, relatively speaking, the woman is heavier. Okay? So we can conclude that the woman is heavier since have a bigger Z-score. Okay, let's look at part B. Part B says, suppose that woman weighs 90 pounds. Is her weight considered unusual? Yes, think about unusual. In general, we say unusual is any number that's probability of having under 5%. The chance of happening in the data is under 5%. So or is outside of the 95 percentile. You can also say that. So let's calculate it. Let's calculate the Z-score. Let's see if it's outside of the 95 percentile, right? Or whether it's considered unusual or not. Let's see. There's two ways to do it, right? Let me do the Z and Z. So Z is equal to X minus mu over standard deviation. X is the weight of that woman, which is 90. And the mean weight for women is 156.5. And the standard deviation for women is 40. So we get approximately negative 1.66. Okay, so let's think about it. We know that 95% of the data is within 2 standard deviations of the mean. So if I would draw it, we know that. I'll do another normal curve here. I wish I made more space. So from negative 2 to 2 with a standard normal, we know that in the middle here, this is 95%. According to the empirical rule. 95% in here, meaning that on the top tail here is 2.5% total, and the bottom here is also 2.5%. Well, negative 1.66 is within the 95%, is within that, which is negative 1, somewhere here. Let me draw it, somewhere here. So it's actually in the middle 95%. So we'll say it's not usual. So let's write it. So we'll answer the question. We'll say this is not usual since her weight is within 2 standard deviations of that mean. That means her weight is within 95% of all the average weight of all women in that age group. So for part C, what interval represents the usual weight of a man 20 to 29 years old? Again, we say unusual if it's outside the 95%, consider unusual outside the 2 standard deviation of the mean. So that means unusual will be less than the negative 2 standard, below negative 2 standard deviation or over 2 standard deviation. That means I can find under and over. So let's find the point that separates the bottom, the left of the 2 standard deviation. So we'll say 2 minus mu minus 2 sigma, 2 standard deviation below the mean. And we also want to find mu plus 2 sigma, 2 standard deviation above the mean. So let's plug it in and do it. So we say any way that is under 80.6 pounds or over 285.4 pounds will be considered unusual. So usual weight will be weight between 80.6 and then 285.4 pounds. So in interval notation, I can write it as from 80.6 pounds to 285.4 pounds. That will be weight that considered usual. Okay, let's do one more problem about z-score. So for problem number 4, the average blood pressure is 120 and with a standard deviation of 12. Blood pressure is a bell shape. So I'm going to find round z-scores to decimal place. So let's do it. So what is the z-score for a person with a blood pressure of 95 mmHg? Okay, let's write down the given information. We say mu is 120, which is given. That's a population average. So mu equal to 120 with a standard deviation of 12, sigma equal to 12. And we want to find the blood pressure for z-score for with a person have a 95 mmHg. So blood pressure for that person is 95. Right? So notice that this is one person, so I'll use X. So X represents the blood pressure for that person. So let me convert to Z. So we'll say Z, using the formula, we'll say X minus mu over standard deviation. X is 95 minus the mu is 120 over the population standard deviation, which is 12. And calculate that. And I want to round to 2 decimal place. It's a negative 2.08. Right? That will be the z-score. So let's do part B. What is the z-score for a person with a blood pressure 140? Okay, again, one person. That notice it's only one person, so the X is 1.4 for that person. X equal to 140. Using the same calculation, we will. Okay, so who has a more extreme blood pressure? So when I would draw the normal curve, and I will find that the person with a 140 is on the right of the normal curve, where the bell curve, where the person with 95 blood pressure is below the curve. So we consider these two here. We say extreme is a person's weight is within outside the 2 standard deviation of the mean. Notice that below this is 2 standard deviation, below this 2 above. So notice that 95, the person with 95 blood pressure is out below 2 standard deviation of the mean, where 140 is still within 2 standard deviation of the mean. So therefore, the person with blood pressure of 95 is more extreme. So let's write it. Okay. So I said the person with blood pressure of 95 mmHg has more extreme pressure since the z-score is outside mu plus and minus 2 standard deviation of the mean. Let's do one more of involving z-score. So the height of a man and women are normally distributed with men 70.1 inches with a standard deviation 2.5 inches. Women have a mean height of 63 inches with a standard deviation of 2.8. What is the z-score for both? Again, this is just same as before. So to do this type of question, you just convert them to z-score like you did before. Convert the height for men for z-score, height for women in z-score. Just write down the given information. On the given information, I get notice that the mu for the mean for a man is 70.1. Right, and the standard deviation of 2.5, and the mean for women high is 23 with a standard deviation of 2.8. So I write down the given information. Now let's convert using z-score. So I say z is equal to x minus mu over standard deviation. So now let's plug it in and calculate. and we calculated, I got the z-score for men is 0.76, where the z-score for the woman is 1.79. Now notice that on a z-scale, 1.79 is greater than 0.76, therefore the woman is relatively taller compared to the man. Okay, so I say the woman who is 68 inches is relatively taller compared to the man who is 72 inches, since the z-score for women is greater than z-score for men. Alright, this completes the review. Thank you for watching the video. I'll see you next time.